Alright, let's look at one that's maybe a little bit more involved than the previous ones. So let's walk our way through this one again. So first step was simplify. Now this one does have a little bit that we can work with. So x squared minus 9 is going to be a difference of squares problem. So that's going to factor into x plus 3, x minus 3. And then on the bottom, our denominator, this one actually factors out pretty nice too to be x minus 3 and x plus 1. Now this one you find out something else actually does happen that didn't happen earlier for some of our problems, and this is going to actually take us back to that idea of the whole. If you look at this one, x minus 3 happens on the bottom and on the top, so that cancels out. So we're actually left in simplified form with x plus 3 over x plus 1. So that took care of our simplification, but because we crossed off x minus 3, if I do x minus 3 equals 0 and solve it, I get x equals 3. At that point, and we won't do it right now, but at that point, there's actually going to be a hole in our graph. So we'll come back to that in a little bit. So there's a little star to worry about. Alright, now if you remember our y-intercepts, we just let our x's equal 0. So on this one, that turns out pretty easy because I just have to do 0 plus 3, 0 plus 1, so I get 3 over 1, which is 3. So my only y-intercept is up at y equals 3. So 0, 3. My x-intercept, remember we let the numerator equal 0. So for this one, we just have to do x plus 3 equals 0 and subtract 3 and get x equals negative 3. So 1, 2, 3 over here. There's my only x-intercept for this problem. Alright, fourth thing, vertical asymptote. Only thing on the bottom is x plus 1. So we're going to do x plus 1, set that equal to 0 and solve, and we're going to get x equals negative 1. So at negative 1, for x, we have our vertical asymptote. There we go. Horizontal asymptote, we're back to the start here, second degree or second power over second power. So they're equal. So we're going to take a look at lead coefficient, which is 1 over 1. So y equals 1. So there is our horizontal asymptote. So far nothing out of the ordinary from the one we've already done. Now, here's where we get a little bit of a change, nothing drastic. Our regions to the left, we've got a couple things that we probably need to look at, and mainly because of that issue with our x-intercept at negative 3, but we've got a hole at positive 3. So we're actually going to have our region number 1 over here, or region number 2 over here. So this side it's already figured out for us. The point that we found is below the horizontal asymptote to the left of the vertical asymptote. So again, we can let those become our magnets, come up here, and come down here. So region 1 is taken care of. Now region 2, not too bad. We already have a point, so we know we can draw our curve, but there's one thing we want to do is that hole at x equals 3. So when we do this one, we want to take 3, plug it in, and see what we get here. So if we do that, 3 plus 3 on top is 6, 3 plus 1 on the bottom is 4, so 6 over 4 reduces to 3 halves, or 1 1/2. So we'll go over to x equals 3, 1, 2, 3, and up to 1 1/2. And what's going to happen is we're going to have an open hole here, which means when we draw our curve, it's going to come down to this point, then the curve is broken, and then we're going to finish up going like the magnet towards our vertical asymptote. Now the significance of that hole down here, that's the value that would make our function undefined. So that's why x can exist at x equals 3. So there's our next picture. Alright, we have one more to look at here, and this will deal with our oblique asymptotes. So let's look at our function. Right, on this one, this is going to be the function we're going to deal with. F of x equals x squared minus x minus 2. And again, I'm having trouble making the electronic pen right here. And that's our numerator. Our denominator is going to be x minus 1. So let's set up our picture here. Alright, so again, step 1 was to simplify. So on this particular problem, the top does factor, and it's going to get us x minus 2, x plus 1, and the bottom is going to give us x minus 1. Now again, this time we didn't end up canceling anything because nothing's alike on top and bottom, so it's going to help us later, but for simplification, that's all we can really do. Alright, y-intercept comes next, so we let the x's be 0. So if I have a 0 here and here and here, they go away. I get negative 2 divided by negative 1 is just 2. So we go up to 0, 2, and we put our point. X-intercepts. For the x-intercepts, we let the top and find the zeros. So we've got x minus 2 equals 0, and we have x plus 1 equals 0. So I'm going to add 2, and I'm going to subtract 1. So at x equals 2, and at x equals negative 1, now I've got my x-intercepts. Right, that brings us up to our vertical asymptotes, which we said we let our denominator equal 0 to solve that for finding our domain. So if we add 1 to each side, we get x equals 1. So our vertical asymptote, and our only vertical asymptote, is going to be here at x equals 1. Our horizontal asymptote, well, in this case we've got the top is a 2, which is greater than the bottom, which is 1. So that tells us there's no horizontal asymptote. But this is exactly 1 larger. So that means we will have an oblique asymptote. Now, like I said, we kind of talked about oblique but haven't looked at it yet. Here's where we go with our oblique and what to do with this one. We take what we've got on top, x squared minus x minus 2, and we do our division. Now I'm going to do long division on this one, even though the example we've got here is x to the first minus 1, so first degree and constant. I could do synthetic with this if I want to, but just to show you what's going to happen. We do first divided by first, so we're going to get x, so x times x is x squared, x times negative 1 is negative x. Draw the line, change the signs, cancels, cancels, I get negative 2. So for this particular problem, I can't take x into negative 2, I'm done. The remainder, no effect. What I get on top, I do y equals, and that becomes the equation of the oblique asymptote. So in this case, that's just like y equals mx plus b. It's going to have a y-intercept of 0 and a slope of 1. So this one is going to take on this effect. And obviously, I can't draw straight at this time of night on an electric pad. But you get the idea. So there's my oblique asymptote. So this time what we've got a whole bunch of things happening here. But what's actually happening is we're going to end up coming with a curve from here down, touch this, and then keep getting closer and closer to our oblique asymptote. Same thing on this side. We're going to get closer like a magnet to our oblique asymptote there, ignore the little swerve in that, and come down towards our asymptote on this side, and there's our picture. So that's how you'll set up dealing with oblique asymptotes.